Imagine holding the entire universe in your hand. Impossible, right? The vastness of space, the countless stars and galaxies all condensed into something you can grasp. But in a way, you already do. Every tiny object you hold is a universe in itself, filled with countless molecules and atoms. We often think of space as vast and empty, filled with stars and galaxies light years away. The night sky is a reminder of the infinite expanse above us. But there's another universe, invisible to the naked eye, teeming with activity all around us. This microscopic world is just as complex and fascinating. This is the world of molecules. These tiny entities are the building blocks of everything in existence. Molecules are the fundamental building blocks of everything we see, touch, smell, and taste. They form the essence of our material world. From the air we breathe to the water we drink, these molecules are omnipresent. From the food we eat to our own bodies, they are the foundation of life itself. Everything is made up of these tiny particles. They are the unseen architects of our reality. They are so small that millions of them could fit on the period at the end of this sentence. Yet their impact is monumental. Yet despite their size, molecules are incredibly powerful. They drive the processes that sustain life and shape our environment. They determine the properties of everything around us. The hardness of metal, the transparency of glass, and the fluidity of water are all dictated by molecular interactions. They are the reason why water is wet, why iron is strong, and why materials behave the way they do, and why sugar is sweet. These tiny particles influence our sensory experiences. Join me on a journey into this fascinating microscopic world. We'll delve into the mysteries that lie beneath the surface. We'll explore the secrets of molecules, uncover their hidden powers, and understand their roles in the grand tapestry of life, and discover how they shape our universe in countless ways. From the smallest particle to the vast cosmos, everything is interconnected through the world of molecules. So what exactly are molecules? Let's dive into the fascinating world of these tiny entities. Imagine a set of Lego blocks. These colorful pieces can be connected in various ways to create different structures. Each block is like an atom, the smallest unit of an element. Just as each Lego block has its own shape and color, each atom has its own unique properties. You can combine these blocks in countless ways to create different structures. The possibilities are limited only by your imagination. Similarly, atoms join together to form molecules. These combinations can result in simple or complex structures. A molecule is simply two or more atoms held together by a special force called a chemical bond. These bonds are like the connections between Lego blocks. These atoms can be the same, like two oxygen atoms forming an oxygen molecule, which we breathe. Oxygen is essential for life. Or they can be different, like two hydrogen atoms and one oxygen atom combining to form a water molecule. Water is vital for all known forms of life. Just like Lego blocks, the arrangement of atoms in a molecule determines its properties. The way these atoms are arranged can change everything. For example, the simple change in how hydrogen and oxygen atoms are arranged makes all the difference between life-giving water and explosive hydrogen peroxide. This shows how crucial molecular structure is. The diversity of molecules is astounding. There are millions of different molecules, each with unique characteristics and functions. From simple molecules like water to complex ones like DNA, the molecule that carries our genetic code, the possibilities are endless. DNA is the blueprint of life. Each molecule has a unique story to tell, a tale written in the language of atoms and bonds. Understanding these stories helps us comprehend the very fabric of our universe. We've established that molecules are formed when atoms bond together. These bonds are the glue that holds the universe of chemistry together, creating everything from the air we breathe to the complex structures of living organisms. But what exactly are these bonds and what makes them so strong? Understanding chemical bonds is crucial for grasping the fundamentals of chemistry and the interactions that govern the material world. Atoms are bound together by a force called a chemical bond, which is essentially an exchange or sharing of electrons between atoms. This exchange creates a stable arrangement, allowing atoms to achieve a lower energy state. Imagine atoms as dancers, and electrons as the music that draws them together. Just as dancers move in sync to the rhythm, atoms move in response to the forces exerted by their electrons. When atoms share electrons, they form a stable partnership, much like two dancers moving in perfect harmony. This shared movement creates a bond that is both strong and flexible. There are different types of chemical bonds, each with its own unique characteristics. These bonds can vary in strength, length, and the way they influence the properties of the molecules they form. One common type is a covalent bond, where atoms share electrons equally. This type of bond is often found in organic molecules, which are the building blocks of life. Another type is an ionic bond, where one atom donates an electron to another, creating oppositely charged ions that attract each other. This bond is typically found in salts and other minerals. These bonds are not static. They are dynamic forces that constantly push and pull. The interactions between atoms can change, leading to the formation and breaking of bonds, which is the basis of chemical reactions. The strength and nature of these bonds determine the properties of the molecule. For instance, the way atoms bond can affect a substance's melting point, boiling point, and reactivity. For example, the strong bonds between carbon atoms are what make diamonds the hardest natural substance on Earth. These bonds create a rigid, three-dimensional structure that is incredibly difficult to break. Section 4. Molecules in action, from breathing to baking. The world of molecules is not confined to a laboratory, it's all around us, playing a vital role in our everyday lives. Take a deep breath. You just inhaled oxygen molecules, which are essential for our survival. Our bodies use oxygen to break down food and release energy. Look around your kitchen. The water boiling in a pot, the sugar dissolving in your coffee, the bread rising in the oven. All these processes involve the interaction of molecules. When you boil water, you're adding energy to water molecules, causing them to move faster and eventually transition from liquid to gas or steam. The delicious aroma of baking bread, that's the result of complex molecules evaporating from the bread and reaching your nose, activating your sense of smell. Even the feeling of warmth on a cold day is due to the transfer of energy from faster-moving air molecules to your skin. Section 5. The restless, microscopic world. Far from being static entities, molecules are in constant motion. Imagine a bustling city street with people rushing about. That's a lot like the world of molecules. They vibrate, rotate, and translate, bumping into each other and their surroundings. The speed of this molecular motion depends on the temperature. The hotter it is, the faster the molecules move. Think about heating up a pot of water. As the temperature rises, the water molecules gain energy and move faster, eventually reaching the boiling point where they escape into the air as steam. This constant motion is essential for many processes. It allows molecules to mix and interact, which is crucial for chemical reactions to occur. For example, the digestion of food in our bodies involves a series of chemical reactions, all fueled by the ceaseless motion of molecules. Section 6. Breaking and making bonds. Transformations of matter. The world of molecules is dynamic and ever-changing. Bonds are constantly being broken and formed, leading to the transformation of matter. We see this every day in simple processes like melting ice, burning wood, or even digesting food. Consider what happens when you boil an egg. The heat causes the proteins in the egg white to denature, meaning their carefully folded structures unravel. This exposes hidden parts of the proteins, allowing them to form new bonds with each other. The result? The liquid egg white solidifies into a firm, rubbery texture. Even the air we breathe is a testament to the power of molecular transformations. Plants use sunlight to convert carbon dioxide and water into glucose, a simple sugar that serves as their food source. In the process, they release oxygen into the atmosphere, a vital gas for animals like us. Section 7. The unending exploration of the molecular world. We've only just scratched the surface of the incredible world of molecules. From the smallest atom to the largest biomolecule, there's still so much to discover and explore. Scientists are constantly developing new tools and technologies to delve deeper into this microscopic realm. Understanding molecules is crucial for tackling some of the world's biggest challenges. From developing new medicines to creating sustainable energy sources, the possibilities are endless. By unraveling the secrets of molecules, we can unlock a future filled with exciting possibilities. So, the next time you take a sip of water, breathe in a lungful of air, or marvel at the colors of a sunset, remember the invisible world of molecules that makes it all possible. It's a world of endless wonder, waiting for you to explore.